Now let's look at another problem which is related to contiguous allocation problem called fragmentation. For the fragmentation problem, it can be further divided into two categories: external fragmentation and internal fragmentation. First, let's see the external fragmentation. In the previous slides, we have learned three storage allocation strategies, which are first fit, best fit, and worst fit. And also we have mentioned that the best fit will produce the smallest leftover hole compared to other solutions. And also for first fit, according to the simulation statistic result, on average with size n process, the size of a leftover hole is 0.5 n, so which is too small to fit other processes. Therefore, both first fit and best fit will produce a smaller leftover hole which cannot be used by other processes. So under this situation, the external fragmentation may be happened, which means we have a list of holes, but all of them are too small to fit a newly coming process. However, the total size of those holes together can satisfy a process request, but it is not contiguous. So for this kind of a problem, we call it external fragmentation. On the other hand, the other type of a fragmentation is called internal fragmentation. For the internal fragmentation, the allocated memory space may be slightly larger than requested memory space due to the several reasons. And the mainly reason due to the fixed size partition or alignment. Because in nowadays general purpose operating system, so each memory block or memory partition must be the integer multiply of 4 bytes, or in other words, the integer multiply of 32-bit of word. So for example, the system requires a 17 bytes process request. However, due to the fixed size partition or alignment, the system will allocate at least 20 bytes of memory space to this process. Then 3 bytes of memory space will be wasted. And this size difference is memory internal to a partition, but it cannot be used by any other processes. So for this kind of a problem, we call it internal fragmentation. From the previous description, we may know that for the internal fragmentation, it is inevitable. However, the external fragmentation problem can be solved. So there are several ways to address the external fragmentation problem. We can reduce external fragmentation by compassion. So we can shuffle memory contents and place all the free memory together in one larger block so that it is large enough to be used by other newly coming processes. However, two conditions are needed to satisfy the compassion requirements. The first one, the relocation must be dynamic. The other one, it has to be done at the execution time. So which means we have to apply execution time binding strategy. For the other two binding strategy, due to the absolute code reason, so they cannot be used to implement a compassion mechanism. And also, if moving all processes toward one end of the memory and all holes to the other end, so these actions will bring too much overhead to the system. So that's the downside for using compassion mechanism. Fortunately, we have another possible solution by allow non-contiguous memory space. As we already mentioned that the external fragmentation problem is mainly caused by contiguous allocation strategy. So how about we break this rule? We use other allocation strategy that allow non-contiguous memory allocation to address this external fragmentation problem, which will be discussed in coming slides. It is called paging memory allocation mechanism.